Hello and welcome back. In this week's stuff, we're going to continue looking at section 4.4, talking about our first and second fundamental theorems of calculus, more with functions defined by integrals and all of that stuff. What we're going to look at today, all the notes are going to be in that packet that you have titled section 4.4, functions defined by integrals in class examples. And I'm going to warn you that what we're dealing with today will absolutely be one of your 6 free response questions on the AP exam in May. Every single year for the past 20 years, there has been a question involving the material that we're looking at today. So this is particularly important. And please make sure that you are asking me questions if you have questions by email or coming to our Google Meet session to go over things. But this is something that will definitely be on the AP exam. Before we start to get into this, you also have a sheet on some color. I'm not sure if it's green or salmon or purple. I don't remember what color I used. But a sheet titled Tools We'll Need to Study Functions Defined by Integrals. You will probably want to have that out. And a lot of stuff in here is stuff that we talked about earlier in the year when we did our curve sketching stuff. A function's increasing when its derivative is positive. A function has a relative minimum where f prime changes from negative to positive, things like that. We're going to need to refer to that sheet. So please do make sure you have that with you as well. I think I'm going to make the video pause so you can take a moment to get these 2 sheets out, section 4.4, functions defined by integrals in class examples, and tools we'll need to study functions defined by integrals. All right, we are going to get started with problem number 1. G of x is the integral from 2 to x of f of t dt. We've got a graph of f shown over here. We've seen these things before. These are just our functions defined by integrals. I think you can probably handle, after last week's stuff, I think you can probably handle doing part A, finding g of 0 and g of 4. So how about you take a moment right now and try g of 0, g of 4, and send those answers into Edpuzzle. Okay, so g of 0 is going to equal the integral from 2 to 0 of f of t dt. Oh, I don't really want to do that. I'd rather go from 0 to 2, so I'm going to make this negative the integral from 0 to 2 of f of t dt. That's negative. Okay. 0 to 2, that looks like a triangle to me. Base of 2, height of 2, negative 1/2 times 2 times 2. We're going to get 2 inside here, so we're going to get negative 2. For our answer, g of 0 is negative 2. Then we need to find g of 4. G of 4 is going to equal the integral from 2 to 4 of f of t dt. Well, as we go from 2 to 4, that's a quarter circle, so that's going to be 1/4 times pi times radius, which is 2 squared. 1/4 times pi times 4 should be getting pi from that. By the way, pi, the Greek letter, is spelled P-I, not P-I-E. I've been seeing some people send P-I-E in Edpuzzle. How about you just write it as P-I? And there shouldn't really have been anything new in part A. But now we start getting into some new things. Part B, I want to find g prime of 0, so the derivative of my function defined by an integral, and g double prime of 0, the second derivative of my function defined by an integral. Before we go on to that, we need to get a couple formulas down. G of x is the integral from 2 to x of f of t dt. That's the formula that I gave you. If I want to find g prime of x, that means I need to find the derivative of my function defined by an integral. Well, that's just our second fundamental theorem of calculus that says the derivative, the integral, they cancel each other out. You're going to replace the t with the x. You're going to get f of x. G prime of x equals f of x. if I want to go a step further and find g double prime of x, that's just going to equal the derivative of f of x. The derivative of f of x is f prime of x. G double prime of x equals f single prime of x. Here's what this means as far as interpreting the rest of this problem goes. If I want to know information about g of x, I'm going to do the integral from 2 to x of f of t dt. I'm going to do some signed area things, like we've already been doing. If I want information about g prime of x equals f of x. This is the graph of f of x. If I want information about f of x, I just need to use the y values on my graph. So if I want to get information about g prime of x, I need to use the y values on the graph of f of x. G double prime of x is f single prime of x. F prime represents the slope of the graph of x. If I want information about g double prime of x, that should be the slope of the graph of f of x. And you know what? Maybe I shouldn't have done this. Maybe we should have taken a look at letter B before getting into the interpretations. Let's take a look at B. I want to find g prime of 0. According to my formula over here, g prime of 0, that's just going to equal f of 0. So I'm going to write that down. How do I find f of 0? Well, I have the graph of f of x over here. F of 0 means tell me the y value when x is 0. Well, what is the y value when x is 0? It's 0. G prime of 0 equals f of 0 equals 0. And as far as the work goes, you do need to show throughout all of the things in this packet the connections between g and f. So g prime of 0, don't just tell me it equals 0, tell me it equals f of 0, which equals 0. Now, g double prime of 0, according to our formula, should equal f single prime of 0. F single prime of 0 means the slope of the graph that we're looking at. Here's the graph of f. I want to find the slope when x equals 0. Well, I think f prime is 0. That's just going to be my slope there, which is 1. Yeah, I definitely think I should have gone through these before labeling the ideas over here as signed area, y values, and slope. But hopefully you see how I'm getting those. Moving on to part C. I need to find the interval or intervals where g of x is increasing. Justify your answer. This should remind you of stuff we did earlier in the year. Where is g of x increasing? Well, here's where I'm going to turn to my tools we need to study functions to find my integrals. And the definition of a function decreasing is where the derivative of that function is negative. F of x is decreasing where f prime is negative. So in this case, I shouldn't have said decreasing, I should have said increasing. F of x is increasing where f prime is positive, which means in this case, g of x is increasing where g prime is positive. But what is g prime? G prime, according to my formulas, g prime is just f of x. I want to know where g prime of x is positive, which really means where f of x is positive. Now, you have the graph of x. I think I'm going to zoom out a little bit. I have the graph of f. I want to know where f is positive. That means I need to be looking for where the y values on my graph of f are positive. I think I'm going to say between 0 and 4. And then between 4 and 6. I'm looking for places where f of x is positive. I'm not including 4 because at x equals 4, f of x, which is g prime of x, is 0, which isn't positive. What's my justification? Because g prime of x, which equals f of x, you got to make that connection in every single problem between the g's and the f's, it is positive over there. Next page. Part D, I want to find the critical values of g and determine if they correspond to relative maxes, relative mins, or neither. Well, critical values occur where g prime of x, which equals f of x, equals 0 or is undefined. Can you tell me where g prime of x, which equals f of x, is 0 or is undefined? Well, f of x equals 0, where the y values on my graph are 0, I'm thinking there, and there I'm thinking x equals 0, and x equals 4. Now, do I have a relative max, do I have a relative min, or do I have neither? At x equals 0, g prime of x, which is f of x, is changing from negative values of f to positive values of f, which means negative values of g prime to positive values of g prime. Well, where g prime changes from negative to positive, I'm going to have a relative minimum. X equals 0 is a relative min. Why? Because g prime of x, which equals f of x, changes from negative to positive there. X equals 4. What do you think I'm going to have at x equals 4? A relative min, a relative max, or neither? Well, at x equals 4, f of x is not changing sign, which means g prime of x is not changing sign. This is going to be neither. You still have to justify it. So why is it neither? It's neither because g prime of x, which equals f of x, doesn't change sign. Neither because x equals 4, at x equals 4, g prime of x, which equals f of x, does not change sign. Next, points of inflection of g. Points of inflection occur when the second derivative is changing sign, so where g double prime of x changes sign. Which means where f single prime of x changes sign. You've got the graph of f. You want to know things about f prime. Should you be looking for where the y values on your graph of f are changing sign, or where your slope on the graph of f is changing sign? I think because we have f and we want to know about f prime, I need to look for where the slope is changing sign. I think I'm going to have points of inflection at x equals 2 and x equals 4. Why? Because g double prime of x, which equals f single prime of x, changes sign there. I want to see if you can do part F. I think you can probably figure that out. Send in your answer and make sure you also send in the justification. So where is g of x concave down? I'm looking for where g double prime of x is negative, which means where f single prime of x is negative. So where the slope on the graph of f is negative, I am thinking between 2 and 4. Why? Because g double prime of x, which equals f single prime of x, is negative. One more. Oh, this has nothing to do with anything we've been doing with our increasing, decreasing, whatever. I want to find the derivative at 0. Well, it's been a little while since we've done derivatives, but what rule are you going to have to use to find the derivative of that thing? I'm hoping that you said quotient rule. I'm going to go use my quotient rule, and I'm going to get h prime of x equals low g of x d high times 2 minus high 2x d low g prime of x. Draw the line and square below. H single prime of 0 equals g of 0 times 2 minus 2 times 0, that's going to be nice, times g prime of 0 over g of 0 squared. I think all you need to do now is figure out what g of 0 is. I guess also g prime is 0, but it's not really going to matter so much because that whole piece becomes 0. Go find g of 0. There are a couple ways I think you can do this. Well, g of 0, according to our formula up here, g of 0 is just the integral from 2 to 0 of f of t dt. Integral from 2 to 0 of f of t dt. I don't want to do that. I'd rather do negative the integral from 0 to 2 of f of t dt. That's going to give me negative 1/2 times 2 times 2, negative 2. The other way we could have done that is just realize we already did that in part A. That works as well. But now I can plug that in, and I'm going to say h prime of 0 equals negative 2 times 2 minus 0 over negative 2 squared. Negative 4 over 4, we're going to get negative 1 for that answer. I'm going to pause the video so you can get caught up on anything you need to get caught up on. So what we're really going to do for the rest of this video is just look at some variations on these ideas. I tried to make sure in this packet that all the different things they could ask you show up somewhere in here. So let's take a look at problem 3. No, sorry, I didn't mean 3, I meant 2. Consider the graph of f of x, which equals the integral from 1 to x of g of t dt, where g of t is the graph shown below. I want an equation of a line tangent to f of x at x equals 3. First thing I'm going to do, I'm going to get my 3 formulas written down. F of x equals the integral from 1 to x of g of t dt. See if you can go create your formulas for f prime of x and f double prime of x. What does f prime of x equal? F prime of x is the derivative of this thing. I'm going to use my second fundamental theorem of calculus, which means the derivative and integral cancel. You plug in the x where the t was, and you get g of x. So what's f double prime of x going to equal? That's just going to be g prime of x. And I'm going to just keep coming back to this code every time I need to figure out some values. Find the equation of a line tangent to f of x at x equals 3. Okay, tangent line y minus y1 equals m times x minus x1. I know x is 3. To find my y1, I need to find f of 3. And to find my slope, I need to find f prime of 3. I think you can probably go from there. Use these formulas to find those values. And I'm going to ask you an Edpuzzle to tell me what f of 3 is and what f prime of 3 is. Okay, so f of 3 is going to equal the integral from 1 to 3 of g of t dt. Base is 2. Height is 1. 2 times 1 is going to give us 2. F prime of 3 is going to equal g of 3. G of 3 is looking like 1. So I think we're good there. Which means my tangent line, y minus 2 equals 1 times x minus 3. That's it. Letter B, absolute extrema of f of x. Absolute extrema. What do you remember about that? To absolute extrema, we need to use what? I hope you said candidates test. And if you didn't, well, that's also something included on your tools we'll need to study functions defined by integrals. I need to go use the candidates test. So I first need to find my critical values, places where, okay, so my critical values are where f prime of x equals 0. Can you tell me the critical values? Where does f prime of x equal 0? According to my little code up here, f prime of x is g of x, so I'm looking for where g of x equals 0. That's going to happen at x equals. Okay, so I've got the graph of g. I want to know where the y values are 0. I'm thinking here, here, here. -3, 0, and 4. So now, I need to set up my candidates test. X, f of x. In addition to the critical values, I also need to include the endpoints in here. So I'm going to put -4 in there, -3, 0, and 4. Well, what's f of -4? Well, according to my formula, f of -4, that's a function defined by an integral. F of -4 is the integral from 1 to -4 of g of t dt. I don't think you're really going to do that. I think you're going to really make it negative the integral from -4 to 1 of g of t dt. Take a moment, go find that signed area, and change the sign of it. Tell me what f of -4 is. Well, I've got a triangle above the x-axis, okay. 1/2 times base is 1, height is 1, 1/2 times 1 times 1. I've got I don't want to do a trapezoid. How about I just do a triangle, a rectangle, and a triangle. I've got a triangle I've got to zoom out so you can see the graph and my work at the same time. I've got a triangle below the x-axis, minus 1/2 times 1 times 1. I've got that rectangle, minus 1 times 1. Another triangle, 1/2 times 1 times 1. Then I have above the x-axis another triangle, 1/2 times 1 times 1. I could have just made this triangle and this one cancel, made that one and that one cancel. Either way, by the time you're done, you should end up with -1. It should end up being +1. How about you go find f of -3? Let's see. So -3 to +1. You know what? I'm going to cheat a little bit. I'm going to make this triangle and this one cancel, leaving me just with these two pieces down here. So minus 1/2 times 1 times 1. Whoops. Because we're below the x-axis. Then another minus 1 times 1. I'm thinking this is -3 halves. So +3 halves for that one. Tell me what am I looking for next? F of 0 is. F of 0 is the integral from 1 to 0 of g of t dt. That's negative the integral from 0 to 1 of g of t dt. That's negative. Okay, 0 to 1, that's a triangle above the x-axis. 1/2 times 1 times 1. I am thinking -1/2 over there. Go find f of 4. Let's see, I've got a rectangle and a triangle. 2 plus 1/2, I'm thinking 5 halves for that. In this problem, I asked for coordinates. I know usually we say the absolute max is this occurring at a particular x value, but here I wanted coordinates, so I might as well give coordinates. Let's see, max, I think this one's our max. Min, I think this one's the min. I think our absolute max has coordinates at 4, 5 halves, and our absolute min has coordinates at 0, comma, negative 1/2. I'll make this pause so you can finish getting any notes you might need. Okay, we have a few more variations we need to look at. So, turning the page. Take a moment and read number 3. This is different. I did not give you a function defined by an integral. I just gave you the graph of f prime. You know what? This is exactly what we did back in Unit 4 when we did our curve sketching stuff. Sections 3, 3, 3, 4, all of that. For example, in part A, where is f of x increasing, I'm looking for where f prime is positive. But this is already the graph of f prime, so you're just going to tell me between 0 and 4 and between 12 and 16. Why? Because f prime is positive. There's nothing new on page 4 at all. How about you take a moment and see what you can do in B, C, and D. Relative minimum occurs where f prime changes from negative to positive. Okay, well, this is the graph of f prime. I want to know about f prime, so I'm looking at my y values over here. I'm thinking x equals 12 is where those y values are changing from negative to positive. So I'm going to say x equals 12. I just wanted x values, not coordinates. Do not tell me 12 comma 0. More about that in a moment. X equals 12 because f prime changes from negative to positive there. Don't tell me 12 comma 0 because I want to know where f has a relative minimum. Well, the y coordinate would be f of 12. We don't have f of 12. We've got f prime of 12. We can't figure out f of 12 yet. Part C. Where is f concave up? Where f double prime is positive. That means if you have f prime and you want to know about f double prime, that means where the slope of f prime is positive. Where do we have a positive slope on that graph? Looks like between 0 and 2, then between 8 and 12, and then between 12 and 17. I shouldn't include 12 because right at 12, the slope of f prime is undefined because we have a sharp turn over there. What is going on? Because f double prime is positive. Oh, I think I might have just given away the next one. Where is f double prime undefined? That means where the slope of f prime is undefined. I have an undefined slope at x equals 12 because there's a sharp turn. I'm not differentiable. So we can see both of them. But there also is another place. It's a little tricky to see over here, but there is a vertical tangent line at x equals 4. So we're going to include that one as well. Let me pause this. So you might be wondering why we're doing this now, other than the fact that the logic is similar logic to the stuff we did in problems 1 and 2. Well, there is a new piece that we need to look at. Parts E, F, and G. In part E, I'm telling you f of 4 is 3. I want you to find f of 12. Okay, so first of all, I need you to think. If I want information about f prime, you use the y values. And if I want information about f double prime, you use the slope. If I want information about f, though, what might I have to use? We're going to have to use signed area things like we kind of saw in 1 and 2. Problem is I don't have a function defined by an integral. So what I'm going to do instead is create my own integral. And I'm going to make use of the first fundamental theorem of calculus. Watch this. I'm going to set up an integral from 4 to 12. And I'm going to choose those two numbers because those are things that I was given in the problem. I know that the integral from 4 to 12 of the graph that I have of f prime of x dx by our first fundamental theorem of calculus. I'm going to find the antiderivative. I'm going to plug in 12 minus, I'm going to plug in 3. Well, the antiderivative of f prime is f. I'm going to get f of x from 4 up to 12. The integral from 4 to 12 of f prime of x dx is going to equal f of 12 minus f of 4. Now, what is the integral from 4 to 12 of f prime of x dx? You're going to go do a signed area thing. I'm below the x-axis, so I'm going to do negative 1/2 times pi times, let's see here, it looks like my radius is 4, so 4 squared. F of 12, that's the thing I'm looking for. And f of 4, well, I told you f of 4. That's why I had to give you that value. We're going to get an equation like this. This will become negative 8 pi equals f of 12 minus 3. And I'm going to finish this by adding 3 to both sides. I'm going to get f of 12 equals 3 minus 8 pi. I'm doing signed area ideas, but because we didn't have a function defined by an integral, I basically created my own definite integral and did a little bit of algebra to solve for the value that I'm looking for. Let me show you another one. Telling you again that f of 4 is 3, I want you to find f of 0. I'm going to set up an integral between 4 and 0. But because I'm going to go do some signed area things from the graph, I always want to go from lowest to highest. So how about I make it the integral from 0 to 4 of f prime of x dx. On the other side of my equation, this is going to equal f of 4 minus f of 0. Tell me what the integral from 0 to 4 of f prime of x dx is. Semicircle. 1/2 times pi times 2 squared. That's going to equal f of 4, I know that, that's 3. F of 0, I don't know that, that's what I'm looking for. I'm going to get this. 4 divided by 2, that's 2 pi equals 3 minus f of 0. Solve that thing. How about we subtract 3 from both sides? 2 pi minus 3 equals negative f of 0. Divide everything by negative 1. F of 0 is going to be 3 minus 2 pi. There you go. How about you see if you can do letter G? See if you can do G and tell me what f of 17 is. I'm going to integrate f prime from 8 to 17. F prime of x dx, this is going to equal f of 17, what I'm looking for, minus f of 8. Okay, as we go from 8 to 17, I've got myself a quarter circle and then a triangle. Make sure you go to 17, not 16. I'm going to get, let me zoom out, I guess, negative 1/4 times pi times 4 squared equals f of 17. Wait, hold on, I'm not done. That's just from 8 to 12. Then I need to add in this triangle over here from 12 to 17. So plus 1/2 times 5 times 2. That's going to equal f of 17 minus 5. Negative 4 pi plus 5 equals f of 17 minus 5. Add 5 to both sides. I am thinking that this final answer is going to be f of, you can't see that, f of 17 is going to equal 10 minus 4 pi. And I'm hoping you're seeing the similarities, but also differences between the problems we've looked at so far. Okay, moving on. Page 6. Number 4. Consider the graph of f of x, f prime of x shown below. F of 1 is negative 2. Wonderful. Find the absolute minimum of f of x on negative 4, 4. Well, absolute minimum means I need to use the what? I really hope you just said out loud, candidates test. Oh, good, we're going to use the candidates test. So I need to figure out where the derivative of f is 0. Where is f prime of x 0? Oh, I've got the graph of f prime here. So where is that 0? I am thinking x equals negative 2, x equals 1, x equals 4. I'm going to set up my candidates test. X, f of x. Negative 4, negative 2, 1, 4. And I need to find my f values. Well, the deal is, we don't have a function defined by an integral. I need to do what I did in the last problem and create a bunch of definite integrals to help me figure this out. Okay, well, I know f of 1 equals negative 2. How am I going to find f of negative 4? I'm not going to do my work inside the table, because I've got to do a little bit of algebra to make this happen, first of all. I want to deal with negative 4. I want to deal with 1. So how about I say the integral from negative 4 to 1 of f prime of x dx equals f of 1 minus f of negative 4. I can get this by signed area. I know this. That's what I'm looking for. Let's see here. I have a triangle above the x-axis, 1/2 times 2 times 2, minus triangle below the x-axis, 1/2 times 3 times 2. That's going to equal f of 1, that's negative 2, minus f of negative 4. Okay, 2 minus 3 equals negative 2 minus f of negative 4. Negative 1 equals negative 2 minus f of negative 4. Add 2 to both sides. 1 equals negative f of negative 4. F of negative 4 is negative 1. Next, I can cheat a little bit. I'm looking for the absolute minimum. X equals negative 2. If I wanted you to find a relative minimum, well, at x equals negative 2, I think you'd have a relative maximum, because f prime is changing from positive to negative there. A relative maximum can't possibly be an absolute minimum, which means, you know what? I don't even have to do this. Let me write out my justification here. I'm skipping this one because this gives a relative max, which can't be an absolute min. So I can ignore that. Oh geez, next one's also actually really easy. What's f of 1? I know that f of 1 is negative 2. You know how I know that? I know that because I told you f of 1 was negative 2. Last one, there's no way around the last one. So you know what, I think you can probably do this. Go set up a definite integral and tell me what f of 4 is. I think I'm going to come up here and do my work up here. Integral from 1 to 4 of f prime of x dx equals f of 4 minus f of 1. Okay, I want to go from 1 to 4. That's a triangle. Base is 3, height is 2. F of 4 I don't know. F of 1 I do know. Okay, 3 equals f of 4 plus 2. Subtract 2 from both sides. I'm thinking f of 4 is 1. I wanted to know the absolute minimum value. That means the y value. That means the f of x value. What's my lowest value? Right over there. My absolute minimum is negative 2. Next, tangent line to f of x at x equals negative 3. Y minus y1 equals m times x minus x1. x1's negative 3. y1 is f of negative 3. You need to make an integral and find that one. M is f prime of negative 3. I think you can get that one. You take a moment, work through this problem, send in your answer to the entire equation of the tangent line to Edpuzzle, please. Okay, so might as well do this one first because it's easy. F prime of negative 3, I have the graph of F prime. I want to know about F prime, so you're just looking at the y value. I think that's just going to be 1. F of negative 3, you got to make an integral here. I know f of 1 is negative 2, so I'm going to say the integral from negative 3 to 1 of f prime of x dx is going to equal f of 1 minus f of negative 3. Go from negative 3 to 1. I've got this little triangle over here, base of 1, height of 1. I know you can't see my work, but I'm doing a half times 1 times 1, minus this triangle down here, a half times 3 times 2. And that's going to equal f of 1, which is negative 2, minus f of negative 3. Okay, I'm back. Here's my work. A half minus 3 equals negative 2 minus f of negative 3. I'm going to add 2 to both sides and get a half minus 1. It's just going to be easier this way, I think. I don't know. Half minus 1 is negative a half. That is negative f of negative 3. So f of negative 3 is positive a half. Am I still on the screen? Oh, I'm still on the screen. Wonderful. We're going to get y minus a half equals 1 times x minus negative 3 times x plus 3. And that's your tangent line. Let me pause this so you can get anything copied down you need to. One more. Oh, there's only one part to this. We've got f prime. I want to know where f of x has an absolute max. Candidate's test. But I've got a problem. I don't know how to find the area underneath this thing. That's not really going to work so well. I'm not sure how to do this. Hopefully, maybe, you remember when we did our optimization topic, real life maximum minimum problems, and we had to find absolute maxes and mins. We used the candidate's test when we could. But sometimes we had to use something we called the global justification. I'm going to do something like that here. Notice, first of all, where are our critical values? Critical values occur where f prime is 0. Just one critical value, and that's happening at x equals negative 3. X equals negative 3, I think, is going to be a relative minimum, because f prime is changing from negative to positive there. I've got a relative minimum. What I need to know is because f prime is negative everywhere before here and positive everywhere after there, I'm decreasing everywhere before, I'm increasing everywhere after, that point has got to be where we have our absolute minimum. Because there's only one critical value, and I am decreasing everywhere before there and increasing everywhere after. Let me write this out. Because f of x is decreasing everywhere before x equals negative 3. Why? Because f prime is negative there. And increasing everywhere after x equals negative 3. Why? Because f prime is positive there. The absolute minimum must occur at x equals 3. And that's all I wanted. I didn't need the value, I just needed where it was happening. Did I do anything with this? Not at all. Didn't affect anything. That was just sort of there to throw you off, maybe to make you think candidate's test, but then realize we can't actually do candidate's test. Instead of candidate's test, I'm using my global justification language. You would not have been able to do this if there was another critical value somewhere else, and then you started changing from increasing to decreasing or something like that, then you wouldn't have been able to use this rationale. So hopefully it would have been something that you could have used candidates test on. And on the AP exam, it would have been. When you go to do the homework, please use this packet as models for the different types of problems. I'm going to make sure the homework is a mix of the functions defined by integrals and the here's the graph of f prime, you tell me things about f. And I think that next Wednesday, I usually do the Google Meet sessions to go over homework. I think for anyone interested in joining that one, we might also spend a little bit of time taking a look at a couple actual AP free response questions that use these things, just to give you a sense of how to use this stuff and to give you a little bit more practice. See you later.